Okay, we're going to look at and review some of the notes that we took last week on the properties of exponents. And we're going to look at the handout that you were given of properties of exponents in solving exponential equations. Alright, so the first rule we have here is a to the m times a to the n. When you multiply exponents, you're actually adding, when you're multiplying these powers, you're actually adding them to consolidate them as long as they have the same base. A is the base, so up here I'm just going to write a number here, 7 to the 5th power. Alright, 7 is called the base, and 5 is called the exponent or power. Okay, so now you know which ones I'm referring to when I say base. So they both have the same base a, so we say a to the m plus n. We would add their powers. Alright, so we're going to look at this example here. They both have the same base of 5, so I'm going to add their powers, and their powers happen to be binomials, so I need to just combine like terms. So it's going to be 5 base, it is not going to be 25, it's going to be 5. Rewrite the base, that according to our rule, and then add the power. So 2x minus 4x is a negative 2x, and negative 3 plus 5 is a positive 2. Okay, so I added like terms and then rewrote it here as a single power. 5 to a single power. Remember, when you're using these help videos, they're going to be kind of short. So if you're stuck on something, stop it, go back to it, watch it again, or pause it if you're trying to take notes. Let's look at rule number 2. A to the m divided by a to the n. When dividing these exponential expressions, you need to subtract their power. So it's going to be a to the m minus n. And you can do that as long as they have the same base. Alright, so when we look at this example over here though, I have to use property number 1 to consolidate the numerator and denominator to make them one single base. So I'm going to do that first. 2 to the x times 2 to the 3x plus 4. According to property number 1, I need to add their powers and put them at above the same base. So my base is 2. X plus 3x is going to be 4x. And then plus 4 because it's no like terms for the constant. Alright, the next denominator is going to be 2 because it's the same base. 2x plus x is 3x. And then 1 plus a negative 5 is a minus 4 or negative 4. Alright, now that we've consolidated this to look like this rule here, we are going to subtract the powers. So it's going to look like something like this. 2 to the 4x plus 4 minus a grouping. So I must distribute the negative. I must distribute this negative to everything thereafter. So that's going to make it a negative 3x and a positive 4. Alright, so I'm going to write that. Negative 3x and a positive 4. So 4x minus 3x. Let me go ahead and write my base. I need to do that first. Alright, 4x minus 3x is x. 4 plus 4 is 8, a positive 8. So that would be my final answer. Alright, rule number 3. This will be the last one I do for this video clip, and then I'll be posting another one later of the last 3 rules. Alright, a to the m raised to the n power. When you raise an exponent or power to another power, you multiply them. So this is going to be a to the m times n. Okay? So now let's look at our example. We've got 2 to the 3rd power raised to the x minus 2 power. So according to our rule, we're going to say 2 to the 3 times x minus 2 times, and I'm just rewriting the second one. There's nothing to do to it yet. So what this means is this 3 is multiplied to the whole binomial, which again is distribution. So that's really going to be 2 to the 3x minus 6 times 2 to the 2 minus 2x. Okay? So now I'm going to use, now we're down to going back and using rule number 1. I am multiplying these with the same base, so I can consolidate by adding their powers. So 3x minus 2x is x. Negative 6 plus 2 is a negative 4. 2 to the x minus 4. Alright, we're going to stop here, and I will post another video later in the day for 4, 5, and 6.